I first want to get this video started by trying to solve this query right here. So our goal is to try to list the name and the price of all products that are more expensive than all the products in the toys department. So we can probably answer this query with only the products table because we're just talking about naming and pricing of products. So to solve this query, we need to take a look at all the different prices of products that are specifically in the toys department. Taking a look at the data inside of here, it looks like there is only one product in the toys department right now. So that's this first record right here, and it has a price of $876. So we essentially want to find all the other products that are more expensive than $876. So if we take a look through here, we'll see that there's only one other record that's more expensive. The record with ID 6, so it looks like it's a mouse that's in the grocery department for some reason, whatever, and it has a price of $989. So ultimately, we would want to find this row right here. And that's what we would try to find if we were trying to answer this query. Let's think about how we would actually write some SQL to answer this thing. Well, there's definitely an easy way and a hard way around going about this. So let's take a look first at the easy way, of course. So one way we could try to answer this query is to write out something like what you see right here. So something like select name and price from products, and then we want to find all the different products where their price is greater than $876, because you and I were able to verify and make sure that the most expensive product in the toys department was $876. Now, why is this kind of the easy way out? Well, not only is it kind of the easy way out, but it's also really cheating. We are only able to write this query right here because you and I can visually inspect all of our data and notice that the most expensive product in the toys department is $876. But in the real world, we might very easily have way too many products to do that kind of visual inspection. So if we have a ton of products, then we can't very easily just scan the list and say, oh yeah, that item right there, that's the most expensive one in the toys department. If we have thousands or even millions of different products, we can't do that visual inspection. We would have to write some query of sorts to find the most expensive product. So with that in mind, this very simple query, the one that we start off with right here, would probably not work out by itself. We would actually have to break this into two separate queries, or two separate steps. The first query would be intended to just find the most expensive product in the toys department. That would give us the 876, and then we could write a second query that actually looks like this right here, where we would put in for 876, we'd put the result of the first query, where we found the most expensive product in toys. So ultimately, we might visualize that in this sort of fashion. We might do an initial query where we try to find the most expensive product in the department of toys. We would then take the result of that query right there and stick it into a second query, specifically into that spot. Now, anytime that you get into this kind of scenario right here, rather than writing two separate queries and sending them off to the server separately or your database separately, we can instead combine these two separate queries down into one by using something called a subquery. So when we do a subquery, we're essentially taking one or more queries and kind of merging them all together in some way. Let's take a look at how we would combine these two specific queries down into one by going back over to pgsql.com. So to combine these two queries into one by using a subquery, we would first write out the outer query, or essentially the second one that we want to write. In this case, this is the second query, so we're going to write that one out first. So we would put in select name and price from products where the price is greater than, and then this right here, this is where we would want to have the first query, the one where we need some value from to complete the outer one. So if we want to insert or stick in another query inside of here, we would put in a set of parentheses. By putting in a set of parentheses, that creates a subquery. So inside of here, we can write in a second query. The second query will be executed first by the database. The result of it will be taken and then provided to the outer query. So inside of these parentheses, we could write this entire initial query, the one that's going to give us the max price of all the products in the products table where the department is equal to toys. So we would write out that first query, essentially, or the initial one that we want to run inside of those parentheses. So something like select max price from products where department equals toys. And toys should be in single quotes, like so. Now, when you write out the inner query, you are not going to put any semicolon at the very end. We only put a semicolon at the very end of the outer query. Okay, so let's now try running this and seeing what happens. Well, it looks like I've got some pretty realistic prices here. It looks like they are all prices that are more expensive than $876. So I'd say that this is probably working out correctly. All right, so we've taken a look and gotten at least an initial impression on subqueries, but of course there's a lot more to them than just this. So let's go over some notes and things you need to understand around subqueries in the next video. We just got our first taste of subqueries. Now, I gotta be honest with you, very much like joins, remember we spoke about joins a good bit so far in this course, subqueries are known in the world of SQL as being a little bit challenging to understand. In my opinion, the reason for that is that we can use subqueries in many different locations in another query. Let me show you a very extreme example. So I'm going to show you a query that has several different subqueries inside of it. Just so you know, this query doesn't really do anything. It's pretty much pointless. It's just to show you how many subqueries in so many different locations you can embed. So take a look at this. There are 4 separate subqueries inside of here. There's one in our select statement. There's one inside the from, one inside the join, and one inside the where as well. So one of the reasons that understanding subqueries is challenging is that we can use them in many different locations. That's something that you and I are going to focus on in the coming videos. We're going to focus on how we can use subqueries in different locations, and of course, why we would in the first place. Before we get too far into that, however, I want to really understand what's going on here and why having a subquery in different locations is challenging at all. The reason that making use of a subquery in different locations is challenging to understand is that whenever we write out these subqueries in different spots, we have to change the type or the shape of data that is being returned from the inner query. So here's our first taste of this. And don't worry, I'm going to give you a lot more on this topic. So if this first discussion is confusing, don't sweat it. In this really large, kind of pointless query right here, we have 4 separate subqueries. Each of them, except for the inner 2, are being used to produce a different shape of data. The very first one, inside the select statement, is producing a single value. The 2 inside the from and join statements are producing a source of rows. And then finally, the last one down here inside the where clause is producing a single column. Understanding where to put these different types of subqueries, so one that produces a value, one that produces a set of rows, and one that produces a single column, is the real trick to understanding this subquery stuff. So with that in mind, we're going to take a little detour here, and we're going to focus a little bit on understanding the shape of data that comes back from any kind of arbitrary query. So these are going to be, again, just our first taste of this, and we're going to take a look at some other examples very shortly. I want to imagine each of these 3 queries right here, and I want to think about the shape or the structure of data that comes back when we execute this query. So for example, if we wrote out something like select star from orders, given the current structure of our orders table, where it has several different columns and definitely many different rows inside of it, if we ran this query, I would expect to get back a result that has many different rows and many different columns inside of it. Likewise, if we did something like select ID from orders, I would expect to get back many different rows, but one single column. And then finally, if we did something like select count star from orders, I would expect to get back one single row and one column, so essentially a single value. Whenever we get back a single value, or essentially one row and one column from a query, we refer to that as a scalar query. Just a little piece of terminology that you might see floating around here and there. So to really cement this idea very quickly, let's go back over and run these 3 different queries. And we're going to see the structure of data that we get back from each one. Okay, so back over here, I'm going to first do a select star from orders. I'm then going to run that. And sure enough, pretty much no surprise here, we get back many different rows, 4 in total, and many different columns and many different rows. If we then update that to be just select ID from orders and run that, we get one column and many different rows. And then finally, if we do a select count star from orders, That's going to tell us the number of rows inside the orders table. And if we run that, we get one single row and one single column. All right, so again, just our first taste of this. We're going to take a look at a couple more queries like this and just start to think a lot about the shape of data that is coming back to us. And then once we feel really comfortable with that, we're going to take this idea back over to the world of subqueries, and you're going to see that integrating subqueries into any other query is going to be rather easy and straightforward. So quick pause and continue in just a moment. We're now starting to think a little bit more about the shape of data that comes back from a query. So let's now take this idea of the shape of data that comes back to us and apply it to the world of subqueries. All right, so as we saw just a moment ago, we can insert different subqueries in different locations in a query. And as I mentioned, each of these different subqueries in these different locations must return different shapes of data. So the first scenario that we're going to consider is putting in a subquery into a select statement. If we want to add a subquery into a select statement, we must add in a subquery that's going to result in a single value. So in this case, if we want to add in a subquery right here, it must be a subquery that's going to give us back just one single value, or just one row with one column. So for example, we might write out a subquery inside of here that looks like this. We are trying to select the max price out of our entire table of products. Only one value is going to come back from this subquery. We're asking for the max price, so we're going to get just the max price out of all the price values. Because this subquery returns a single value, we are allowed to insert it into this select statement as a subquery. Let's go and try to execute just this query by itself. We're going to verify that it does give us just one single value, and then we'll try to integrate that into a larger query. Okay, so I'm going to do a select max price from products. And if I run that, I'll see very easily that we get back one single value. So again, I'm going to repeat it for a third time now. Because we get back one single value from this subquery, we are allowed to insert it into a select statement. Let's now write out this entire outer query, and then we'll move this subquery into the select statement. So I'm going to delete the subquery for right now and replace it with a select name and price. And then right here, I'm going to put in a set of parentheses to indicate that we're going to add in a subquery. So I will say select max price from products. Notice that I'm not putting in any semicolon at the end of this subquery or anything like that. It is just the subquery by itself. So then we can finish off the rest of the query. We can say from products where price is greater than 867. Now we should be able to run this. And yep, we get back a result. Now in this case, having a subquery inside of here is not super meaningful. I'm not too worried about showing you very meaningful queries right now. Instead, I really just want to focus on understanding the rules of subqueries and where we can put different types of data. So showing the max price next to every single product, it's not super useful. Nonetheless, again, I really just want you to get used to the idea of making use of subqueries and where we can insert each kind of them. All right, so let's take a look at one more example of this. So here's another example. We've got another query right here that's hopefully going to give us back one single value. We are asking for a price from products, specifically for the product with an ID of 3. That should give us back just one row and one column. Now we are making a little bit of an assumption here. We are assuming that there is a product with an ID of 3. If we were asking for a product that did not exist, that would give us back a null result. So we're kind of bending the rules here just a little bit, but you and I know very well that this will return one single value for right now. So it's good enough for our purposes. So because this is going to return one single value, again, we are allowed to insert this as a subquery inside of a select statement. So again, let's try to execute this subquery by itself and just verify that it gives us back one value. So I'll say select price from products where ID equals 3. I'll run that. Yep, we definitely get back a value. We get one single value, and because of that, we can use this inside of a select statement as a subquery. Then we can, again, write out the large query, or the outside one. We'll get name, price, and then insert the subquery right here. So select price from products where ID equals 3. And then we'll add in our from products where price is greater than 867. So now we can run this, and yep, it works again. Now, in this case, you'll notice that we get a little bit of an interesting result here. We're seeing that all of our different products have a price of 10 and a price of 10. That's because we've got two values of price coming out, where we have essentially two columns that are named the exact same thing. And so the tool that we are using here is essentially pgsql.com is getting just a little bit confused because we have two identically named columns. So we could fix this up by renaming the result of the subquery. So right after the subquery, I'm going to put in an as, how about ID3 price. And now if I run that, we see the correct result. We've got the price of each individual product and then the renamed column right here. Okay, so we've learned in this video, and I'm going to repeat it for the fourth time, if we have a subquery that returns a single value, we can make use of that inside of a select statement. So now that we understand this first rule around subqueries, let's pause right here and take a look at the second rule in the next video. Time for a quick exercise. So in this exercise, we're going to take a look at that phones table once again. Our goal is to print out the name and price for each phone. And then as a third column, we're also going to print out the ratio of a phone's price against the max price of all phones. So ultimately, we're going to have a table or result with 3 different columns and many different rows, 1 row for each individual phone. So we'll get the name of each phone, the price, and then this phone's price divided by the price of the maximum phone. Now, without a doubt, we could take a look at this table and find the maximum price. There it is right there, $3.99. But as we discussed just a little bit ago, it's kind of hard for us to always assume that we can visually inspect a table and get some value out. So rather than trying to manually divide the price to calculate that third column right there by $3.99, you should instead write out a subquery. A subquery that's going to find the max price. So go ahead and give this a shot, and we'll take a look at a solution, of course, in just a moment. All right, let's take a look at a quick solution here. Without a doubt, we know that we want to get 3 different columns: our name column, price column, and then the ratio column, where we calculate the ratio between a phone's price and the max price. Don't forget, we also want to rename that third column to be called price_ratio. So I'm going to put down a select, and I'll select the name and the price. And then here's the little hard part. We're going to take a look at the current phone's price and divide it by the result of a subquery. So this is where we are going to find, inside the subquery, the maximum price of all phones. Inside the subquery, we'll do a select max price from phones. So that will give us the maximum price among all phones, and we'll divide the price of the current phone by that. Let's also not forget, at the end of this little expression right here, we also want to rename this column to be called price ratio. So I'll put in an as price ratio. And then finally, we'll do a from phones to make sure that we run the select for every different phone. Okay, let's check our solution and see how we're doing. Well, looks like we are good to go. Awesome. In this video, we're going to take a look at placing a subquery into a from clause. So we're going to once again study the different kinds of data, or the structure of data, that must be returned from a subquery in order for us to use it inside of a from. Now, understanding subqueries and from statements is going to be just a little bit more challenging than understanding a subquery inside of a select. And that's because a subquery inside of a from is a little bit more flexible. Whenever we put a subquery into a from clause, we can return a wide variety of different structure of data. It's all about making sure that the outer query is compatible with the subquery. What does that mean? Well, I'll show you what that means in just a moment. First, I want to consider a subquery that you see right here. So this is a subquery that we want to somehow write out and then use as a source of data inside of an outer query. The goal of the subquery is to calculate the name and the price divided by the weight of each individual product. So price divided by weight, we're going to refer to that as a price-weight ratio. You can imagine that maybe this is going to calculate how profitable it is to ship any given item, assuming that maybe we have to pay more money to ship an item that is heavier. That is our subquery. Let's go and run just that subquery by itself right now and investigate the structure of data that comes back from it. Okay, so back over here, I'm going to do a select name and price divided by weight, and then I'm going to rename this column right here. I'm going to apply an alias to it with as price weight ratio. I'll then say from products, and that's it. That is our subquery. Now, if we run that, we'll see the name of all of our different products along with our price to weight ratio. So this is a source of data that we can make use of inside of a from clause. Remember that a from clause in general is specifying a set of rows that we want to use inside of our query. So whenever we write out a subquery inside of a from clause, we're essentially saying that there is some kind of special source of data that we want to use in this particular case. Now, before I show you one follow-up diagram to help you just really understand this entire picture, there's one more thing I want to mention very quickly. Whenever we make use of a subquery inside of a from clause, we must apply an alias to the result of the subquery. So this right here, where I say as p, that is setting up an alias. We can now refer to this source of data, whatever the result of the subquery is, anywhere else inside of the outer query by referring to p. Now, again, I'll give you a good example of that and tell you more about it in just a moment. I just want to throw it out there right away because as soon as you start putting a subquery into a from clause, you're going to see an error around this alias stuff if you don't put it in. Okay, so enough of all these kind of like corner cases. Let me give you a little bit more big picture and really walk through the example with this price to weight ratio stuff. Okay, so we're going to again consider just the subquery by itself. The result of the subquery is it's going to take a look at all of our different products. We're going to take a look only at the columns name, price, and weight. Price and weight are actually going to kind of fall off here because we're just doing some math on them and we are getting a new column called price to weight ratio. So we can imagine that our real source of data here is going to be just some column called price to weight ratio. And there's going to be some numbers inside of it that get calculated from the price and the weight. Maybe something like this, who knows? That is our source of data. This source of data is then available to the outer query. We can apply any kind of selects, any froms, any wheres, anything like that that we want to inside of the outer query. So in this particular case, we could try to select the name and the price to weight ratio from this source of data. We can also apply a where to it as well. So we could say where price to weight ratio is greater than 5. Now you'll notice that on this diagram right here, I've got these two boxes and I'm saying that, well, we need to make sure that the outer select is compatible. What does that really mean? The result of the subquery has only columns name and price to weight ratio. So inside of our select statement, if we asked for just price by itself, we would get an error. And that's because there is no price column inside of our subquery. The result of the subquery is just the two columns you see right here. If we ask for a column price, we're going to get an error because that column does not exist. Likewise, if we tried to put in just weight, we would also get an error because in the result of our subquery, there is no weight column. The only columns we have access to are name and price to weight ratio. Same thing with the where clause down here as well. If we try to refer to price, we're going to get an error because that column doesn't exist. If we try to refer to weight, nope, can't do it. We can't take a look at ID. The only things we can take a look at are name and price to weight ratio. Now, at this point in time, you might be kind of curious and thinking, wait, Stephen, why would we even use a subquery here? Well, to be 100% fair, we do not have to write out a subquery in this particular case. We could write out essentially this query by itself and then just apply a where statement to it and it would give us the same result. I'm only showing you this as a very quick, easy to understand example of some of the rules around a from clause that has a subquery inside of it. We'll take a look at an example of why we would want to use a subquery inside of a from clause in just a little bit, but for right now, I just want to understand the rules. Now let's go and try to write out both the subquery and the outer query together. Okay, so back over here, I'm going to delete everything I have, and I will replace it with select name and price weight ratio from And then we're going to put in our subquery right here. This is the source of rows to the outer query. So we will select name and price divided by weight as price weight ratio. I'm going to put a new line inside of here just to give myself a little bit more space. And then to finish off the subquery, we'll put in from products. And then finally, on the outer query, we'll put in our where. We'll say only show rows where the price to weight ratio is greater than 5, like so. Okay, so let's run this. And you're going to see an error right away. So this is an error that you're going to see very frequently whenever you are trying to make use of a subquery inside of a from clause. The error that you're going to see is subquery and from must have an alias. That is the gotcha that I mentioned just a moment ago. Whenever you make use of a subquery inside of a from clause, you have to apply an alias to the result of the subquery. So we could put on here something just like as E being short for products. Now I can run this and we get our result. So we'll see the name and the price to weight ratio. Okay, so at this point in time, I know using this subquery right here doesn't make a lot of sense because we could really just write the subquery by itself and get the same result. But we are going to take a look at a better example of why we would make use of a subquery inside of a from clause in just a little bit. First, I want to consider one other scenario, one other way that we can make use of a subquery inside of a from clause, and then we'll understand why we would do this at all. Let's very briefly take a look at another example of using a subquery inside of a from clause. After that, we'll then understand why we would do this at all. Why do we care about using subqueries inside of a from? So in this particular example, we're going to see that we do not have to return a set of rows or columns from a subquery inside of a from clause. We can return just one single value as long as the outer select statements, the wheres, and so on are compatible with it. So in this case, we're going to write out a subquery that's going to give us back one single value, just one value. Selecting the max from price means let's take a look at the price column by itself, nothing else. And we want to get just the max value inside of here. So in this case, it would be the 989. That is the result of our subquery. It is one row and one column, which we referred to as a value. That's one single value. We can make use of this as a subquery inside of a from clause so long as the outer select or any additional wheres, group bys, and so on are working or assuming that we are making use or providing just one single value. So if we now try to do a select and say something like, give me all the product names, well, that's going to break because we don't have any names here. If we try to ask for, say, the weights, again, going to break because we don't have a weight column. The only thing we can ask for here is just everything. Give us everything, which in this case is one single value. So let's try once again writing out just the subquery and then integrating that into a larger query on the outside. So we'll once again do a select max price from products. Yep, we get just one value right here. So now we will integrate that into a larger outer query. We'll say select star from, and we'll put in our subquery, select max price from products. And then let's not forget to apply our alias right here. So as P. All right, so I'm going to run that, and you'll see that we get the exact same result. So again, this is a scenario where we don't really need the outer query. I just mean to give this to you as an example of, hey, we can provide a subquery right here that gives us one single value as long as the outer selects and so on are going to agree with the structure of data. All right, so now that we have seen that a subquery inside of a from clause can give us either a set of rows and columns or just one single value, let's now start to understand why we would do this. Why would we ever make use of a subquery inside of a from clause? That's the real question here. So quick pause, and we'll take a look at that in just a moment. Let's take a look at why we would ever use a subquery inside of a from clause anyways. So in this video, to understand why we would do that, we're going to try to solve a little query or a little question. I want to try to find the average number of orders for all users. So that essentially would be the total number of orders divided by the total number of users. Now, I want you to know right away that there is more than one way to solve this question. Absolutely. We are going to solve it a very particular way by using a subquery inside of a from clause. We can technically solve this with using two subqueries inside of a select statement as well. Pretty easy, but instead we're going to use a subquery inside of a from clause. All right, so to get started, I want to make sure it's super crystal clear on what we need to do here. In other words, what we are actually trying to calculate. So let's take this data set right here, and we're going to walk through what a correct solution to this question would be for this data set. So one way that we could solve this would be to take a look at all the different user IDs and maybe put them into distinct groups to find out how many orders each user has. So we might say that for the first order right here, it looks like it is an order that was created by the user with ID 5. The next one was for user with ID 3, then a 4, then a 5. We then got a 1, and another 5. So we would read this as saying that the user with ID 5 has 3 orders, user with ID 3 has 1, user with ID 4 has 1, and the user with ID 1 has 2 orders. So now that we've counted up the number of orders per user, we can do a little bit of math. So we've got 3 orders right here, 2 orders right here, 1 and 1. So to find the average number of orders per user, we would take the total number of orders divided by the number of users right there, that's the 4, and we would end up with 1.75 orders per user. So that's what we'd be calculating if we were using this little data set right here. So now that we understand what we are trying to calculate, let's translate all this into the world of SQL. How would we do this same kind of operation using SQL? Well, here's one way that we might go about this. We might decide to do a group by. That's essentially what we just did on that last diagram. We could run a group by on orders, and we could group by user ID. Remember what a group by does? Our database is going to take a look at all the different unique values inside the table, specifically the user ID column. We're then going to create a bucket for each of these different unique values. So we got 5, 1, 3, and 4. We then take each of these different rows and assign them to the appropriate bucket. So there's the first one. This is for user ID 3. Here's 4, a 5. I'm doing this as quickly as I can, I promise. A 1, and then a 5, and finally a 1. Where is that? Right there. There we go. So those are our groups. So now we could use one of those aggregate functions to count the number of records inside of each of these groups. So in this case, we would end up with 3 records right here, 2 right there, 1, and 1. So that's the result of doing a group by and then applying an aggregate function to it. Now, there's just one little problem here. We can definitely write out a query that gets us this far. We can write a query that's going to give us some data source that looks like this, and then we can maybe select the group by product ID and the count for each one. Definitely we can do that. We learned exactly how to do this back in that group by section a little bit ago. Let's write a query just to get this far, and then I want to point out a little problem with actually calculating the average value. Okay, so back over here, I'm going to refresh. Then to write out that group by statement, we would do something like select user ID and count star from orders, and we would group by user ID. That should pretty much be it. So if we run that, okay, that looks pretty good. We've got all the different user IDs and the number of orders that each one has created. So now that we've got this data, well, now how do we actually turn this into an average? We need to now take this column right here, all these different values, and find the average of all those different values. You might try to just wrap the count inside of an average or something like that. Well, you could try that. Unfortunately, we can't nest function calls number 1. Number 2, trying to take the average of count doesn't really make a lot of sense in this case anyways. Remember, a select statement is going to run over all the different groups individually. So when we write a select, we're essentially saying, give us a value at this row for the column product ID. So for this group right here, I want to select product ID and count star. If we try to wrap that count star with average, that doesn't somehow magically mean that we're going to take the average of all the values in that column. Instead, if we could apply average, which we can't, it would give us just, say, the average of the number 3. because that select statement is just operating on that row by itself. So we're now at a point where it would be kind of hard to solve this using just everything we know right now. And this is why we might make use of a subquery. So if we turn this grouping by stuff into a subquery, we could then select the count column and find the average of all the values inside of it. We're essentially saying, okay, we got this far, we've got this data. Rather than trying to select some individual values out of this, we want to use this as a data source. And we want to do a further aggregation on all the values inside of the count column. So that's why we might make use of a subquery inside of a from clause. Let's take a look at what this would actually look like. So I'm going to wrap this inside of a set of parentheses because it is our subquery. I'm then going to put from right in front of it. And I'll do a little bit of reformatting just to make it look nicer. There we go. I will then apply an alias to it. So I'll say as p. I'm also going to apply an alias to count star right here. So count star, I'm going to rename that to order count, like so. So now, without worrying about doing any averages or anything like that, let's just figure out how we can select the count out of this subquery. If we want to just select the count, we would say something like p.order count. We don't have to have the p dot right there. That's just so you understand that, well, that's why we have the alias inside of here. If we want to be more explicit about where this data is coming from, we could say p dot order count. That means it's giving us the order count column out of that p alias table. So we can run this now, and we'll see the order count. And again, we could delete the p dot, and we end up with the same values. So notice how we now have a single column of values. And because we have a single column of values, we can apply a aggregate function to it. In this case, we apply the average aggregate function, so avg, and wrap that around order count. That's going to take a look at all the different values inside of order count, inside that column, and reduce them down to one single value, because that is what an aggregate function does. Okay, so let's run that, and there we go. We end up with about 11 orders on average per user. Now, in truth, the average is not exactly 11. It's being rounded off here because we are storing order count as an integer. So technically, it's something slightly different than 11, but we haven't really discussed conversion of values just yet, so an integer into a decimal value or a float. We'll cover that a little bit later. But 11 is pretty much good enough. It means that on average, a user has 11 orders. Okay, so that is an example of where we would use a subquery inside of a from clause. I want to repeat, you're probably sitting there thinking, Steven, this was too complicated. There's an easier way to do this without a subquery inside of a from clause. Yes, I totally accept that. There are different ways to do this. If you are familiar with some different approaches, yep, totally agree with you. This is just an example of where we might make use of a subquery inside of a from clause. All right, so now that we've seen this, quick pause right here. A little bit more subqueries coming up. Time for a quick exercise. So the goal here is to calculate the average price of phones for each manufacturer. So in other words, we should group by all the different manufacturers and then find the average price of phone for each one. So if we think about that just by itself, I'm just going to give you a little hint here. We might end up with something like select AVG price, and we might want to rename that column to something like as AVG underscore price from phones, and then we would group by the manufacturer. And as usual, double check your spelling on manufacturer. So if we run that just by itself, so I'm going to click on check solution, that will give us the incorrect answer, but it will help us understand the kind of data that we would get back. So we would get back a single column, and inside of it would be a couple of different values. So once you get to that point, you then want to try to find the maximum value within this column. So to do so, you might take this initial query right here and put it into the subquery of a from clause. And that would allow you to then do a further query or a select on this column. So go ahead and give it a shot, and we'll take a look at a solution in just a moment. Let's take a look at a quick solution. I'm going to first begin by writing out the same query that we had just a moment ago. I'm going to select the average price, and I'm going to rename that column to as AVG underscore price from phones, and I want to group by all the different manufacturers. So I'm going to check that solution very quickly just to print out this information once again, make sure we're going down the right track. All right, there we go. So that's our output. It is not yet correct, but we'll fix it up in just a moment. So we've got the average price column, and we've got all the values in there. So now we want to take the result of this query and run a query on top of it. So we're going to wrap this with parentheses. I'm going to do a little bit of reformatting as well. And then in front of the first parenthesis, I'll put in from. So we're saying that we want to use the result of this query right here as the source of data. Now don't forget, whenever we use a subquery inside of a from, we have to apply an alias to it. So I'll apply an alias of as p, p being short for prices. Then we can do our select. So I'm going to select the max from p.avg price, like so. So P right here is a reference to essentially that table. And then we're saying that we want to find the max. And then the very last thing we're going to do, we can see it in the directions. We are told that we want to rename that maximum price value to max average price. So we're going to apply to this select right here and as max average price, like so. Okay, let's go ahead and check our solution and see how we're doing. And after a brief pause, there we go. Very good. In this video, we're going to take a look at subqueries inside of a join clause. Now, I'm going to tell you right now, unfortunately, it's really hard for me to show you a good example of why you would do this with the current data set that we have right now. So the example we're going to look at is going to be kind of pointless, kind of contrived, but it's still going to teach you the basics of how to write a subquery that goes into a join clause. Okay, so enough of that. So the rules here are that we can put in any subquery into a join clause right there, or a subquery at it, as long as that subquery returns some data that is compatible with the on clause. So the actual joining expression right there. Let's take a look at an example of this. We're going to first run the subquery by itself to understand the structure of data that comes back. Okay, so over here, I'm going to do a select user ID from orders where product ID is equal to 3. So this is going to tell us all the different user IDs of people who have ordered the product with ID number 3. If we run it, these are going to be the users who ordered that product. Now in theory, we could use that as a source of data and join it into our users table to find the first name of all the different people who ordered that product. If we think about this in a diagram format, we're essentially saying from the orders table, find us only the orders related to product ID of 3. So that'd be this row right here. That means that we would forget all the other rows, or essentially just dump them. We're then going to use the remaining data right here as the source of data for a join with users. We are joining these two tables together by finding where ID on users is equal to the user ID of orders. In this case, in this diagram, user ID of 5 would match up with that user right there. We can really imagine that we would kind of take this entire row and throw it right there. And then we end up with our join table. We are making use of an inner join here. So for any rows where there is no match, they would all get dumped. So all those other rows get dumped, and we're left with just what you see right here. Now we could select first name, which would give us Michaela out of all this. Now, I just want to point out that the reason that this example is kind of contrived and not super useful is that, well, we could do the exact same thing with a normal join without using any kind of subquery or anything like that. So again, not super useful, but I just want you to understand the mechanics of using a subquery in a join. Okay, so let's go write out the full query now. So back over here, I'm going to select first name from users. We're going to join in some data that is going to come from the result of a subquery. So inside of here, I would select the user ID from orders, and I only want to find the user IDs where this person ordered a product ID of 3. There we go. Now, very much like our subqueries inside of a from clause, we do have to provide an alias for the result of the subquery inside of a join clause. So we are going to provide an alias here of as O, O being short for orders. Then after that, we can put in the on clause, which is going to specify how we're going to join this source of data with users. So in this case, we'll say o.userID. So let's match up the user ID from this source of data with the user's ID, like so. And that should be it. So we can run this. And those are the names of all the people who ordered the product with ID 3. Now, just so you can see that this subquery usage right here is not super useful, we could technically reduce this entire thing, take the subquery out, and just say orders, update that alias right there to orders, and then finally I'll delete the semicolon at the end and put in a where of orders.product ID equals 3, and that would give us the exact same result. So again, not a great example of when to use this, but definitely a good enough example for you to understand the mechanics of using a subquery inside of a join. All right, so I apologize again that I can't give you a better example here. Nonetheless, hopefully we have a good idea of what's going on. Let's move on to the next video where we're going to see the probably most exciting and best usage of subqueries, which is when we make use of them inside of a where expression. So let's take a pause here and tackle that in just a moment. In this video, we're going to take a look at subqueries that are being used inside of a where clause. Now, this is where subqueries start to get really, really useful. So we're going to spend a good amount of time to study some different types of subqueries and some rules around them, and then eventually start to write out some interesting queries. So the last couple of videos, when you're talking about from and joins with subqueries, not quite as useful. You're not going to see them used quite as often. You're going to see subqueries used inside of where statements a little bit more frequently. But of course, it always comes down to the kind of application you are building. Okay, anyways, let's get to it. So in this example, we are talking about using subqueries inside of a where clause. So we really have to think back to how where clauses work in general. Remember, we are going to use where clause to filter out some number of rows. There are a couple of different operators we can use inside of a where clause. Stuff like greater than, less than, equal to, greater than or equal to, in, not in, a couple others we discussed way back inside of section 1. So when we start talking about subqueries being used inside of a where clause, and we start to think about the type or structure of data that is returned from the subquery, a valid subquery is going to be valid or not depending upon the operator right here that we are using. So in some cases, we are allowed to write a subquery that is going to return only one single value. In other cases, if we use a different operator, we might be allowed to write a subquery that's going to return a list or a single column of values. It all comes down to the operator that we are using. I'm going to show you a full list of different operators that we would use inside of a where clause and the different types of data that we are allowed to return from a subquery in just a moment. But for right now, let's just take a look at this first example. So in this first example, we're going to try to write out a query where we're going to show the ID of orders that involve a product or is an order for a product with a price to weight ratio greater than 5. Now I want to point out once again that we could technically solve this query by using a join, just a normal join. And you're going to see that's somewhat frequent or kind of common with a lot of subqueries that we might put into a where clause. You might be able to solve it using a join. But in general, understanding a where with a subquery sometimes ends up being a little bit easier than understanding a join expression. So even though we can sometimes use them interchangeably a little bit, well, sometimes it's just easier to use a subquery inside of your where. Okay, so back to the problem at hand. If we're going to solve this using a subquery, the first thing we might want to do is try to list out all the different products with a price to weight ratio greater than 5. And this subquery right here would do it. Let's run just that subquery by itself really quickly and verify that. Okay, so we might do something like select ID from products where the price divided by the weight is greater than 5. So if we run that, we'll see a list of all the different product IDs where their price divided by the weight is greater than 5. You'll notice that the vast majority of records here do have a ratio that is greater than 5. So if you want to, you could always change this to something like 300, and you'll definitely get a much reduced set here. Maybe something like 50 would be a little bit better. Yeah, that's better. Now we're definitely missing some IDs inside of here. So you'll notice that we are getting back a single column of values. If we get back a single column of values, then we are allowed to use that with an in operator. The in operator, you might recall, is going to check and see whether or not this value right here is present inside of a list of values. So in this case, we are checking to see if a product ID is present inside of the list of IDs that we just got back from the subquery. Let's take a look at this in diagram format. Okay, so here's our table of orders and products. We're going to first imagine what happens with the subquery right here. So in this case, we can imagine that we're going to take a look at all the different products, and we're going to discard any product that has a price divided by weight less than 5. I already did that math for us. This is not exact math, but it's close enough for the purposes of this diagram. So we'd go through here and remove any record with a price to weight ratio less than 5. Well, looks like in this case, it's just the one right there. So we would delete that row. Then out of all the remaining rows, we're going to select just the ID column and nothing else. So all these other columns are going to fall away, and we are left with just this list of values right here. After that, that column or that list of values will be provided to the where clause. So now we're going to take a look at every product ID from the orders table. And we are only going to keep around product IDs where the ID is present inside of this list right here. So we can now imagine that the database is going to go through row by row and check and make sure that this value is present in this list. In this case, it is. So we would keep the first row around. The next value is definitely present. The next one is definitely present. And then 3 right here is definitely not present. 3 is not inside of this list of IDs. So we would drop off that row entirely. And then finally, product ID 1. Yep, it's right there. So that is our final data set right there. We have gone through the entire where clause at this point. And so that now the last thing for our database to do is just select the columns that we actually care about. In this case, it is just ID. So all these other columns would fall away, and we are left with just these IDs right here. Okay, so now that we understand the kind of backstory here and we understand the subquery, let's go write the entire query, so the outer and the inner together. All right, so back over here, I'm going to start from scratch. I'm going to select the ID from orders, and I only want to see orders where the product ID of the order is present in a list. So we're going to use that in keyword. And then we're going to provide that list using a subquery. So inside the subquery parentheses, we'll put in select, and excuse me, wait, let's see, do I have this right? Yep, we got it right. Okay, we're going to select the ID from products where the price of the product divided by the weight is greater than 50 in this case. If we just saw a moment ago, if we use 5, we get too many results, so we'll just go with 50. All right, so let's run this now. And now in theory, these are all the different orders that are for a product with a price to weight ratio greater than 50. Okay, so what we've really learned here is that the different operators that we use are going to influence the structure of data that we are required to return from the subquery. I'm going to give you a more exhaustive list of how the different operators match up to the structure of data coming back in just a moment. The other thing I want to mention here yet again is that technically we could have operated or implemented this entire query right here using a join expression instead. We could have written in a join and then still done a very similar where, and everything would have worked as expected. It's totally up to you whether you want to implement queries like this using a where clause subquery or doing a join. At the end of the day, I think that you'll find that in many scenarios, the performance between the two is actually equivalent. We're going to go into more of this later on inside the course, but all you need to really understand right now is that whenever you provide some SQL to Postgres, it's going to analyze the structure of SQL you put together and try to really understand what you are trying to do. In many cases, Postgres is going to actually rewrite your query for you. And so if you rewrote this as a join expression instead, then it turns out that, well, Postgres might execute the two different queries in exactly the same way. And so you might end up with some identical performance characteristics between the two. That is a discussion we'll have later on inside the course, however. Okay, so pause right here. We're going to take a look at the different operators we can use and the different types of data that we're going to return for each of them as well. In the last video, we established that the operator that we use inside of our where clause is going to influence the type of data or the structure of data that we have to return from our subquery. let's take a look at a table that's going to summarize what operator we're going to use with the different type of data coming back. All right, here we go. So this table looks a little bit confusing. There's a lot of information in it. Let me give you a couple of quick notes. So on the left-hand column on both sides, if you use the shown operator or the provided operator right here inside the where clause, that means that your subquery that is also inside the where clause must return this structure of data. So in other words, if we use a greater than operator inside of where, our subquery must return a single value. If we make use of the in operator, then our subquery must return a single column. If we make use of equal, we must do a single value, and so on. Now on the right-hand side, you'll notice that some of these values look really confusing right here. I'll give you some more information on these in just a moment. Right now, we're just going to ignore them. Last thing I want to mention is that I know there's a lot of information here, and you might be tempted to print this out or just try to memorize all this stuff. I really think that you don't need to try to memorize this. I think you're going to realize rather quickly that a lot of the information in here, or a lot of these different rules, are actually going to end up being kind of rather obvious once you've gone through a couple of different queries. So with that in mind, let's try to write out another query right now where we will make use of a subquery inside of the where clause. As we write the query out, we're going to come back over to this table and we're going to reference and figure out exactly what the structure of data coming back from our subquery must be depending upon the operator that we use. All right, so here's what we're going to try to solve. We're going to take a look at our products table. Our goal is to show the name of all products that have a price greater than the average product price. So to solve this, we're definitely going to need to make use of a subquery. The goal of the subquery is to figure out the second part right here, the average product price. That's what we're going to implement with the subquery. Before we worry about the subquery too much, however, let's just focus on what operator we should probably use inside of the where clause. Once we figure out which operator we should use, we can then figure out the structure of data that needs to come back from the subquery. So in this case, it says very clearly that we want to find products with a price greater than this stuff. So the term in here, the keyword is greater than. That is a sign that we probably want to find where the price is greater than something. So our operator in this case is going to be a greater than sign. Now that we've established that, let's go figure out the structure of data that must come back from our subquery. Okay, here's greater than. So this table is telling us that if we are going to implement a subquery, it must return a single value. And that's pretty much it. That's how we would use this table. All right, so with that in mind, let's now try to write out a subquery that's going to return a single value right here. And as you guess, the goal is to return just the average product price. That's what we want to return. Well, to do this, let's go back over and write out a quick query. So to find the average price out of all of our different products, we might write something like select average of price from products. I'm then going to run that, and I get back a result of 498. Now that definitely looks pretty accurate to me because I randomly generated all this data, and all the different prices range from around 1 to 1,000 or so. So an average price of around 498 sounds pretty much right. The other thing you'll notice here is that we are getting back a single value because we have one row and one column. So this can serve as our subquery. We would take that and put that right here. So select average price from products. All right, probably don't care about the formatting there too much. Well, now that we understand these two parts, we can assemble them together into one big query. So I'm going to go back over, I'm going to start from scratch. I'm going to select just the name from products, and I want to find only the products where the price is greater than. I'm going to put in my parentheses for a subquery, and we'll do a select average price from products. Oh, products. There we go. Okay, so let's run this. And looks good to me, more or less. I'm not entirely sure if this is the correct answer, but I think the query is definitely right. I think this is probably the correct result. The only reason I say that is it's kind of hard for us to actually verify this is the correct data. We might try to print out the price of each of these as well, and then just verify that all the different prices listed are greater than that average price of $4.98. And looking at these, yep, definitely looks like that is the case. All right, so we have now established that we have some subqueries that are going to return a single column when we are using them inside the where clause. And we just saw one where we have a subquery returning a single value. And again, it all comes down to which operator we are trying to use. So let's take a look at another example of this in the next video. Let's take a look at a quick exercise. So the goal here is to write a query that's going to print out the name and the price of only phones that have a price greater than the Samsung S5620 Monty. So that's this phone right here. It has a price of $250, so we only want to print out phones that are more expensive. Now we could very easily write in a query down here that's going to have a where we check to find only phones greater than 250, and we could hard code in the value 250. But remember, sometimes it's really challenging for us to do a visual inspection of a table and try to find some exact precise value. So rather than trying to do a comparison against the value 250, we should instead try to write out a subquery that's going to find the phone called S5620 Monty and get that phone's price. So make sure you do this comparison using a subquery. All right, go ahead and give this a shot, and we'll take a look at a solution in the next video. Let's take a look at a quick exercise. So from the description right away, we know that we want to print out the name and the price of some different phones. And that means we could probably put down a select name and price from phones right away. Then after that, we've got some criteria here. We only want to see the name and the price of phones that have a price greater than that phone, this S5620 Monty. So in other words, we want to take all of our phones with the from phones clause, but then we want to filter some out by using a where clause. And we specifically want to filter out the phones that have a price that is less than some other amount. So in other words, we want to find phones where the price is greater than the price of the S560 Monty. So we're going to put in a subquery inside of here to make sure that we can find the price of this very particular phone. I'm going to select the price from phones where the name of the phone is equal to S5620 Monty, like so. Now we've got a subquery here that hopefully is going to return just one single value. We could possibly have more than one phone with this name, but in this case, in this exercise environment, I'm going to assume that, well, we've only got one phone with this particular name. With this where clause right here inside the subquery, we are only going to get back one row. And then out of that row, we are only selecting one column. So the result of the entire subquery is a single value, which means that it is safe to be used with the greater than operator. All right, so let's go ahead and check our solution and see how we're doing. All right, looks good. And if we do a visual inspection on our results, we've got the S5620 Monty at $250. And looking at all the other prices, yeah, only the Galaxy S and the iPhone 4 have a price greater than. So that means that our results right here definitely make sense. Okay, so this looks good. Let's continue on in just a moment. Let's take a look at another example where we're going to use a different operator. So in this example, we want to show the name of all products that are not in the same department as products with a price less than 100. So in this case, we would take a look at all of our different prices. We would find all the ones that have a price less than 100. In this case, it's this right here. The bacon is in the department movies. So I would not want to show any other product that is also from the department movies. It looks like none of these others are from movies. So I would show all the remaining products' names. And that's the idea. So once again, we need to probably first figure out which operator we want to use. And then from there, we'll figure out the structure of data that's going to come back from our subquery. Well, in this case, the operator we're going to use is kind of prominently displayed in the goal of the query itself for this question. It says not in. So we want to take a look at the department of all of our different products and make sure that the department that we list right here that we're currently iterating over is not present in a list of departments that we're going to achieve through our subquery. So in this case, we're going to make use of not in. So we can go back to our table. So if we are making use of not in, that means that our subquery must return a single column. And as you'd probably guess here, our subquery is going to return back a single column that contains the departments that contain an item that is that has a price less than 100. So as usual, let's go and try to write out the subquery first. The goal of the subquery is to find a list of the departments that have a product with a price less than 100. So for that, we might write out something like select department from products where the price is less than 100. And if I run that, it looks like all these different departments right here have a product inside them that is less than $100. You'll notice that some of them are repeated, such as baby right here. That is to be expected because we're not doing any kind of condensing down logic. We're saying just look at all the different products, find all of them that have a price less than 100, and return their department. So there might be multiple different products from the same department with a price less than 100, as is the case with baby. Okay, so that's going to be our single column of data. So we would put that in right here as our subquery. So select department from products where price is less than 100. That's going to give us back the single column. So now we're going to take a look at each individual department from our products table and make sure that each individual products department is not present in that list right there. Now we can merge the result of these two queries together. I'm going to start off from scratch. I'll put in select name. And even though the question didn't really ask for it, I'm going to print out the department as well. And then we're going to get all of our different rows from products where the department is not in a list that we're going to produce right here. So our list of records is going to be the department from products where the price is less than 100. I'm then going to take a quick glance before we read this, or before we run it. I'm just going to make sure that in the results of this query, I don't see any departments like movies, tools, outdoors, industrials, electronics. I'm going to run that. I shouldn't see anything like movies, tools, industrials, electronics. And I definitely don't see any here. So I'd say that this is probably working as expected. Okay, so that's another example of a subquery. And again, we have made sure, based upon the operator that we were using, that the subquery was returning the correct structure of data. All right, let's take another pause, and then we're going to move on to the right side of the table over here and take a look at some other operators. Let's take a look at another use of a subquery inside of a where clause. This time around, we're going to be making use of an operator that we've not used before to do our comparison. The goal here is to show the name, department, and price of all the different products that are more expensive than all of the products in the industrial department. Let's first get started by walking through a solution with this little sample data set right here. So we would first want to find all the products in the industrial department. It looks like that's just 4 and 5 right here. They are both inside of industrial. So I'm going to pull those two out, like so. We're then going to go through all the remaining rows and make sure that they have a price that is greater than the price of 328 and 796. So we'll start off first with the first product right here as a price of 876. That is definitely greater than both 796 and 328. So the first product would stick around. The second one has a price of 412, which is not greater than all these different values. So we would dump that. The next one has a price of 10, definitely less than the products inside of industrial. So we'd lose that. The next one has a price of 989, which is greater than both these, so it would stay around. And then finally, 298 is less, so we would dump it. So we are left with just these two rows right here. And then we only want to see the name, department, and price. So we would delete ID and weight, and we are left with just that. All right, so that is how we would solve this question. Now that we understand how we'd solve it in kind of a diagram format, let's figure out how we would solve it with SQL instead. One way we could solve this is by doing a max aggregate function on the price of all products in industrial. So we could write out a subquery that was something like select max price from products where department equals industrial. This would absolutely work without a doubt. But for the purposes of this video, I want to show you a slightly different way of solving this. So even though we could use max here and it would be very efficient, just fantastic, we're going to look at a slightly different solution. We're going to make use of an operator that we have not seen before. So this is the same table we were looking at just a moment ago. I just adjusted some of the values a little bit just to make it a little bit more clear. So we're going to be making use of a new operator called the greater than all operator. The goal of greater than all, we're going to put in a value on the right or left-hand side over here. So that might be some price or something like that. And then greater than all is going to make sure that this price is greater than all of the values inside of a column of data. So we're essentially comparing one value, making sure it's greater than all the values inside of a column. This single column right here is going to come from some subquery that you and I are going to write. There are many different variations on greater than all, so we could do a less than all, greater than or equal to all, not equal to all, and so on. There's also a variation on this called sum. Besides sum, there's actually an alias for sum of any. So if you see sum or any, they mean the exact same thing. We'll take a look at what sum and any do in just a moment. For right now, let's just focus on all. Okay, so in this case, let's go back to our kind of original starting point here, where we had a bunch of different rows inside this table. And the first thing we needed to do was find the price of all the different products that were inside of the industrial department. So we would write out a subquery right here that was something like select price from products where department is equal to industrial. So that would give us just these two rows right here. And specifically, we are selecting only price. So we would delete all the different columns except for the price column. So notice how we are now left with one single column. Whenever we are making use of the greater than all operator, so this one right here, we need to make sure that our subquery returns a single column. And that's definitely what we're doing right here. So now we can put in an operator of greater than all. We would use this as our subquery, and everything should work as expected. So we're going to take a look at every row inside of products and make sure that each row's price is greater than all the values in this column. All right, now that we understand the theory here, let's go ahead and write out the actual query. So we would do a select name, department, and price from products where the price of the product is greater than all of the different values inside of a column that we're going to generate right here with a subquery. So I want to select the price from products, spelling error there, products, where department is equal to industrial. And make sure you've got a capital I right here. And we should not have a semicolon at the very end of that line. We should only have a semicolon at the end of the overall query. Okay, so let's now run this. And now in theory, all of these different products right here are more expensive than all the products inside of industrial. And just doing a visual inspection, yep, looks like we got it right. The last thing I want to mention here, just one more time, yes, we could have done a max. We could have found the max price and then done a comparison without all. I just wanted to show you a slightly different way of going about this. Okay, so once again, greater than all, less than all those different variations. We're going to write out a subquery that's going to return a single column. And then we're only going to get past this check if some value, such as price, just as an example, is greater than all the different values listed inside that subcolumn, or less than all, or greater than or equal to all, and so on. Okay, let's take a pause here and take a look at this last other operator in just a moment. Let's take a look at this sum operator as well. The first thing I want you to understand is something I mentioned just a moment ago. Sum is actually an alias for any. So you can make use of the keyword any or sum. Totally up to you. They do absolutely the same exact thing. When we think about sum, let's first consider what happens with greater than sum right here. Let's imagine that on the left-hand side, we have a value like 50. And then maybe as a result of some subquery, we get back two values or two rows in one single column. Maybe the values 20 and 100. So these are meant to represent two values in one column. The sum operator is going to make sure that 50 is greater than at least one of these two values. In this case, 50 is greater than 20, so this would evaluate to true. If the greater than sign was reversed, then we would check to see if 50 is less than at least one of these two values. Well, 50 is definitely less than 100, so again, it would evaluate to true. So that's pretty much it for sum. We're just making sure that one value, which is placed on the left-hand side, is greater than, less than, greater than or equal to, etc. At least one value placed on the right-hand side. So to understand what's going on here, let's take a look at a quick example. So in this case, we want to show the name of products that are more expensive than at least one product in the industrial department. Let's walk through this with the imaginary data set right here, just to make sure that the goal is super clear. The first thing we'd probably do is try to find the price of all products in the industrial department. So we would take these two products right here. And technically in this case, because we're using sum, it's more like a copy, just a very small detail. So then we're going to take a look at all these different rows, and we're going to only keep around the ones that have a price greater than either 328 or 796. So in this case, 876 is greater than 328, so we keep that around. 412 is definitely greater than 328. 10 is not, however, greater than at least one of these two, so we would drop 10. 328 right here is not greater than, it is greater than or equal to, or less than or equal to, but it's not greater than 328, so we would drop that. 796 is definitely greater than 328, so we'd keep that one around. We'd keep around 989, but we would drop 298. And so we're left with this right here. So that's our goal. That's what we're trying to do. All right, so first off, let's imagine what the subquery should be. Well, the subquery, we're going to want to find the price of all the products in industrial. So it would probably be something like select price from products where department equals industrial. Then inside of our where over here, we're going to compare the price, and we're going to make sure that the price is greater than sum of the values listed inside of the column that's coming out of this subquery right here. That's the goal. All right, so let's go run the subquery first and then integrate it into the overall query. So first we do, not sum, but select price from products where the department is industrial. And as usual, make sure you've got single quotes right there, along with a capital I for industrial. All right, so that's all of our different prices. So now we would integrate this as a subquery as a part of the overall query. So rather than rewriting this entire thing this time around, I'll just put in select name, department, and price from products where the price is greater than sum of the values that are going to be listed inside of this subquery. And we take that subquery and toss it in right there. And that's pretty much it. So we can now run this, and there we go. So now in theory, all the different products right here have a price greater than at least one of the products inside of industrial. And this, of course, might include items that are inside of industrial as well. So like right there, that is inside of industrial. Okay, so that's it for sum. Now, sum is one of these keywords where it's kind of hard to show you a very compelling example. This is another one of those things where I'm sure we could come up with a really great data set that would give you a good example of where to use sum, but it's another one of those topics where when you need to use it on a project, your mind is probably going to say, aha, this is where I should use sum. It's something where it's kind of hard to really focus on in isolation, but when you need to use it, you're probably going to think of it pretty quickly. All right, so that is it for subqueries for right now. Remember, the whole big thing around subqueries when it comes to the where clause is that we really want to think about the operator that we are using, because that is going to dictate the structure of data that is going to come back from our subquery. Let's take a pause right here and continue in just a moment. Let's go through a very quick exercise just to practice this idea of subqueries. So in this case, our goal is to print out the name of every single phone that has a price greater than any phone made by Samsung. So you're going to want to go through all these different phones and compare the price of each one to all the phones that are made by Samsung. In this case, there are 3 different ones. So go ahead and give this a shot, and we'll take a look at a solution in just a moment. All right, time for a quick solution. So this problem is rather similar to several other that we went through when we were talking about subqueries in that where clause. In this case, we know that we definitely want the name of some different phones. So I'll start off by doing a select name from phones. So then it is a question of which phones we are going to include. So we probably want to do some kind of filtering here using a where clause. We specifically want to find only phones that have a price greater than all of the different phones that were created by Samsung. So I'm going to use a greater than all operator here. Whenever we make use of greater than all, we must do a comparison against a column of values. So I'm going to make sure that I write out a subquery that's going to return just one single column of values. The subquery itself will probably be a select price from phones. And then we only want to see phones where they were manufactured by Samsung. So I'll do a where manufacturer equals Samsung. And as usual, double check your spelling on manufacturer. Very easy word to get wrong. I'm going to go ahead and check my solution, see how I'm doing. And it looks like we got it. We can also visually inspect our data and make sure that it's correct. So iPhone 4 has a price of $399. Yep, looks like that's the only one that's greater than all the phones that were created by Samsung. Awesome. We have spoken about subqueries for quite a bit, but there's one last topic I want to give you around the world of subqueries. The last topic we're going to discuss here is something called a correlated subquery. To understand what a correlated subquery is, we're going to try to solve another little problem. Now, when you first look at this problem, it's going to sound rather easy to solve. But the more you look at it, the more you realize that it is a little bit challenging. So our goal is to show the name, department, and price of the most expensive product in each department. That is the goal. Let's first kind of walk through this imaginary data set and just make sure that we really understand what we're trying to do. So we would probably want to find all the unique departments to get started. In this case, it looks like the only departments we have are industrial, outdoors, and grocery. All the others are repeats of those same departments. So we would then look at each department one at a time. We'd start off first with industrial, and then we would try to find the most expensive product. So we would compare 876 versus 328 versus 796. Well, the first one is definitely the most expensive, so we would drop those two rows right there, and we have now processed the department industrial. Next up would be outdoors. So we've got outdoors at 412 versus 298. Well, we definitely keep around to 412. And then finally grocery at 10 versus 989. And we would stick around with just 989. So that is what we are going for. We only want to see each department one time, and we want to see the product with the most or the greatest price. All right, now that we understand what we're going for, let's imagine how we would write this out using a subquery. Now that we know what we are going for, let's try to write out a quick subquery. The subquery is not going to be what we are going to eventually end up with, but I just want to put something together so we can start off some discussion about exactly what a correlated subquery is. So I'm going to write in a subquery for right now that is going to select the maximum price from products where the department is equal to industrial. So notice right now that I've got a hard-coded department inside of here. So this is not extremely useful because eventually we want to see each department, not just industrial. Nonetheless, let's just take a look at what is going to happen if we make use of this subquery for right now. Before we do, however, one other quick reminder on how the where clause works in general. So when we think about from and where, the goal of from is to get some number of rows for us to somehow iterate over or fetch. All those different rows are then fed into where. Where is going to be executed one time for each row. So if we think about just the outside query for right now, we would imagine that first we have this row right here come in, and the where gets executed. After that, we then move on to the second row. That's going to come in, the where gets executed. Then on to the third row, where it gets executed, and so on. You get the idea. Now here's the real catch when we start using a subquery. When we make use of a subquery, as soon as we get a row inside of this where right here, the subquery is then going to execute. And it's going to be executed, you can kind of imagine, in the context of this row right here. When the subquery gets executed, it itself might fetch some number of rows and then execute a where for every single one. So in other words, when we are executing a where for just this row right here, we can imagine that the following thing occurs. The subquery runs, we get all of the different rows for products, and then we execute the where for every row that we just fetched. So likewise, just like we just saw with the outer query, the subquery is going to first take a look at that row, execute the where, and then this one, and execute the where, and then the next one, and so on. So you can kind of imagine that this is like a double nested for loop, if you're familiar with a for loop in general. For every row that we're going to iterate over on the outer query, we're going to iterate over all of our different products on the inner query. So it's kind of like a nested for loop. So that is one thing I just want you to keep in your mind for right now. Now we're going to kind of up the complexity here just a little bit. Hopefully that part is clear enough. So I'm going to add in just a little bit of complexity here. I'm going to make a little change to both of these queries. On the outer query, I'm going to tag the from right here with an alias. So we're going to say from products as P1. Remember, by adding in an alias, we can now refer to P1 anywhere inside this query. For example, I could put in P1.price. Now that is not strictly required. We do not have to put in P1.price. But if we do, it's just being very clear and explicit that we are talking about a row from this products table. We're talking about a row that we fetched while executing this from right here. I'm going to do the same thing. I'm going to add an alias over on the subquery as well. Right after products, I'm going to put in as P2. I could then mark department right here as P2.department. So likewise, this is not required. We are just being very explicit and saying that we are talking about a row from the P2 dataset. And in particular, we are trying to refer to the department property on that row. So if we really think about what P1.price and P2.department are doing right now, P1.price is really talking about that cell right there, like this value. And P2.department is really talking about this value. So it's very clear that we can kind of refer to very distinct rows and very distinct columns, like really distinct cells is what I mean to say here, or distinct values, by making use of these aliases. Okay, so now here is the final jump. The last thing we really need to understand what a correlated query is. Remember, we treat this, or we can think of this as being like a double nested for loop. So while this subquery is being executed and we are looping over a bunch of rows, we still have this kind of P1 row out here, like this row right here. And here's the big part. We can refer to values inside of this row on this subquery. So inside of the subquery, we can refer to different values from this outer row. For example, instead of saying P2.department equals industrial, we could instead say P1.department right there. Now think about what this is going to do. First, the outer query is going to execute. We're going to get all the rows from products. We're then going to start to execute this where for the very first row inside that data set. So it's this row right here. When we start to execute the where, we're then going to run the subquery. The subquery is going to go and get many rows from products as well. It's going to tag all those rows as P2. It's then going to pick the first row off the list and execute the where for that one as well. So at this point in time, we've got the first row right here and the first row right here. And we can refer to values from both of these rows inside that where. So in this case, we are saying that we only want to hold around this first row right here if its department is equal to the department of this row over here. If those are equal to each other, then we are going to hold onto that row on the subquery. We're then going to move on to the next one. That'd be the second row right here. And then we would repeat the process. So now the P2 is referring to this row, and P1 is still referring to this row. Because remember, for every row in the outer query, we're going to go through many, many rows on the inner query. Now we're going to take a look at the P2 department, which is outdoors, and see if it is equal to P1 department, which is industrial. In this case, it is not equal, so we're going to discard that row altogether. We're then going to repeat this process. We go on to row 3. Is grocery equal to industrial? Nope. We're going to dump it. How about for 4? Is is industrial equal to industrial? Yes, it is. So we're going to keep it. There we go. And now just one last row right here. Industrial is equal to industrial, so we're going to keep it. So we have now built up a set of rows. We have filtered over everything in products for right now. We applied where to every one of those rows. And now out of all the rows we have remaining, we're going to find the max price. So in this case, the max price is 876 right there. So the value 876 is what comes out of this subquery for this very first row. Just this first one by itself. We get back 876. So now, all we have to do is apply some kind of operator right here that's going to decide whether or not we want to hold on to this row. So we're going to say if P1's price is equal to the max value that just came out of the subquery, then let's hold on to this row. Well, in this case, 876 is equal to 876, so we're going to hold on to that row. All right, so now, hopefully that part, I know I went over it in very long, very great detail, but we're going to repeat this process for just one other row. So this entire process, everything we just went through, is going to occur for row 1, 2, 3, blah, 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 all the way through. Let's skip on to row 4, however. So this is when we process row 4 on the outer query. So we're looking at row 4. We're going to apply the where to it. So we're going to take a look at row 4. And once again, for row 4, we're going to run this entire subquery, which might involve many different rows in its own right. Let me get a copy of row 4 very quickly back up here. There we go. So for row 4 right here, we're then going to execute the subquery. Once again, we're going to take a look at all the different rows from products. So all these different rows. And for each one, we're going to evaluate where P2.department equals to P1.department. So we'll start off right here with row 1. And we'll check to see if industrial is equal to industrial. Yes, it is. So we're going to hold on to it. We're going to take a look at the second row. Outdoors, nope, doesn't matter, don't care about it. Grocery, nope, not the right department, don't care about it. And then we finally get on to industrial, once again. Okay, this is industrial equal to industrial, so we're going to hold onto that row. And then the next one, industrial equal industrial, so we're going to hold on to that one. And then we're going to repeat that process for all the rest of the rows, and that concludes the where. We have retrieved all of our rows, we applied the where, we did some filtering, and this is what we came up with. So now out of these remaining records, we're going to run max price. What is the max price? Once again, it is 876. So from this overall subquery, we return just the value 876. It's going to flow back over here. And we're going to check and see if this row's price is equal to 876. Nope, it is not. It is not equal. So we are not going to include that row in our result set. So what is the impact of these two flows we just went through? We just went through a flow for row 1 and row 4. Well, the result of these two flows is that we ended up getting the max price inside of industrial, and we discarded another record inside of industrial that was not the max price. So this is how we would solve this overall query. We can imagine that the same process is also going to happen for, say, outdoors. We can imagine, I'm just going to show you just one more example very quickly here. So for row 2 right here, we would process the where with row 2. And once again, that means that we're going to run this entire subquery. So we take a look at row 1. Do they have the same department? Nope. So I'm going to drop row 1. We take a look at row 2. Do they have the same department? Yep. So I'm going to hold on to that one inside the subquery. Let's go to row 3. Different departments. Doesn't matter. Let's go down to row 7 because that's the only one that does matter. Same department, they are both outdoors, so I'm going to hold on to it. So now out of these remaining records, I'm going to find the max price. It is 412. That's what's going to be returned from the overall subquery. So that's going to go back here, and we're going to check and see if P1's price is equal to 412. Yes, it is. So we're going to hold on to that record right there. And once again, that's going to give us now the max value or the highest priced product out of the outdoors category. Even if we ran this same process for some other outdoor value like this one right here, the 298, we would not include this 298 value because it does not have a price equal to the 412. Only the original row 2 does right here. Okay, so that is going very far into detail, and I apologize for the length of this video. But now that we've discussed this entire process in great detail, let's go and write out the final query to solve this. Okay, so back over here, I'm going to select name, department, and price from products, and then we're going to do our where. We're going to apply an alias to products right here. We're going to call it P1. And then inside the where, we're going to take a look at the P1 row and ask if its price is equal to a single value that is going to come out of a subquery. And the single value that we're going to calculate here is going to come from select max price from products where, and then once again, we're going to mark the from with an alias, so as P2. And then our condition in the subquery, we only want to take a look at rows where the P1, so that is the outer row, the outer department is equal to the inner department. So I only care about departments identical to the row that we are currently iterating over on the outer query. If they are the same, then we want to include that in our result set. Then out of all the rows we include in the result set, find the maximum price, and then this entire subquery for one individual row is going to reduce down to a value of something like 915. And so we're going to check and see if the P1 price is equal to 915. If it is, great, we're going to include that in the results of the overall query. Okay, so let's run this. And there we go. We should now see each department listed exactly one time, and each record should be the most expensive product inside that category. Let's pick one out at random here. How about the very first one, outdoors? It has a price of $412. I should not see any other results of outdoors. So if I do a find on this page, I don't see any other results for outdoors. And if I replace this with a select star from products where department equals outdoors, I should not see any other products with a price greater than $412. So I'm going to run that, and sure enough, $412 is the most expensive product. All right, so that is a correlated subquery. The term correlated subquery essentially means that we are referring to some row from the outside query in the inner query or in the subquery. We refer to a row in the subquery by applying an alias somewhere, and then we can freely refer to that alias inside the subquery. All right, one more time. I apologize for the very long video here. I hope it was not too boring. Let's take a look at one more example of a correlated subquery in the next video. I promise it will go a lot faster. Let's take a look at another correlated subquery. So in this video, we're going to try to solve this question right here. We're going to try to print the number of orders for each product. So for example, if we consider the first product right here just by itself, the first product has an ID of number 1. So I would want to find the number of orders that are tied to this product. If we look at our orders table, we would take a look at the product ID column, and we would try to find an order with a product ID of 1. In this case, there's one right there. So the first product has one single order tied to it. So I want to print out maybe just the name of that product and then the number of times that it has been ordered. So in this case, it would be just 1. We're then going to repeat that process for every single product. So that's our goal. But there's an additional little requirement on here. I want to try to solve this without using a join or a group by. Now, without a doubt, let me be clear, using a join or a group by or some technique like that is definitely the ideal way to solve this, without a doubt. But we are going to take an alternative approach where we try to only make use of a correlated subquery. And the goal here is to just better understand how correlated subqueries work. All right, so let's walk through a solution to this together. We're going to understand this from a kind of theoretical perspective and then write out the actual query. The first thing I'm going to do is put together the root query on the left-hand side. It's kind of hard to give you a natural lead into this or kind of like show you naturally how to go about this. It is definitely easiest for us to tackle this thing if we just kind of take a look directly at a solution first and understand it. So the outside query that we're going to put together is going to be select name from products as P1. Now you'll notice right away that we've got the alias on here. Remember that when we are making use of a subquery or a correlated subquery, we are almost always going to apply an alias somewhere so that we can cleanly refer to the outside row in the context of the subquery. Now with just what we have right here, we can imagine once again that we're going to take all the different rows out of products. And then each individual row, we can imagine, is going to be fed into that select clause. So we're going to process each row using the select clause. In this case, we have just a select for name. So we can imagine that we're going to take just shirt right there and use it inside the select. So where's the correlated subquery? Well, that's where the magic comes in. Rather than using a correlated subquery, in this case, in a where clause, we're going to instead place a correlated subquery in the select. That's the trick. We can make use of a correlated subquery not only inside of wheres, as we saw in the last video, we can use them just about anywhere. So in this case, we're going to put a correlated subquery right here inside of the select. So I'm going to imagine that our subquery is going to go like right in there. Now I want you to remember what happens when we make use of a correlated subquery. We can imagine that it is like a double nested for loop. So as the outer query goes through every row of products, so first this row right here, and then row 2, and then row 3, and then row 4. For every one of these rows, we are going to take a look at every single row out of some other source of data. In this case, it's going to be orders. So for example, if we put in select something, we'll figure that out in just a moment, from orders, and I'm going to apply an alias to that right away as O1, that means that for every single product that we look at, we're going to take a look at every single order. So for this first row right here, we're going to look at every single order. For the second row, every single order. For the third row, every single order, and so on. So as we process each of these different orders, we have the ability to do some kind of computation or somehow reference the value on this order and compare it against a value on the product that we are currently iterating over. So all we have to do is figure out exactly what different values we want to compare between this row right here and this row right here. In this case, we kind of want to join together manually, so to speak, the product ID from the order and the ID of the product itself. So to do so, we might write out a where right here of O1, so that is the order row that we're currently taking a look at, dot product ID equal to P1.ID. So the where right here is saying I only want to keep around rows from the orders table where the product ID, that is this column right here, is equal to the ID of the product that we are currently iterating over. So in this case, we would say, all right, are these two things equal? Is 4 and 1 equal? Nope, it's not. Okay, so we don't care about that row from the orders table at all. So we then move on to the next order. We'd say, okay, is 2 equal to 1? Nope. Okay, we would drop that, and eventually we would move on to the very last row right here. So we're going to again say, okay, is the product ID equal to the ID of the product itself? In this case, yes, it is. So we would hold on to this as the result of our subquery. So now after our subquery runs, after we've processed the from and the where, we are left with just this row by itself. Now in our case, we want to print the number of orders for each product. So for the select right here, we could put in a count star, and that's going to count out the number of rows that we got from the from and the where. And the result of that would be just 1. And so the subquery overall would return 1. And if we imagine the result from processing the very first product right here, we would end up with a product name of shirt and a quantity or a count of 1. And that's it. All right, I know that this is kind of a nasty thing as you go through it, but you gotta just approach this from the thinking of this is like a double nested for loop, and we have the ability to refer to values on the column, or excuse me, from the row on the outside query inside of the subquery. Let's now go back over and write out this entire thing and just make sure that we get something that looks like a correct result. Okay, so over here, I'm going to put in first just my select. I'm not going to write anything in just yet. I'll put in my from, and we're going to take a look at all of our different products as P1. So then inside the select, I'll add in name because I want to print out the product's name. If we want to be really specific, we could put in p1.name just to make sure that there's no ambiguity there. After that, I'll then put in my subquery. So inside the subquery, for every single product, I want to take a look at all the different rows from the orders table. And I'm going to apply an alias there as well as O1. Now, when we take a look at all those different orders, we want to apply some filtering criteria. So we will add in a where, and we'll say that we only want to consider orders where the order's product ID is equal to P1, so the outside rows ID. So get that big list of orders, pare down the list of rows to just the rows we care about, and then we'll get a count of the rows that we found. And then finally, I'm going to go ahead and rename this entire column right here to as num orders. Not required right there, just doing it so that it's really clear when we take a look at our result set what the two different columns we're going to end up actually mean. Okay, so let's run this and see how we're doing. So now I can see the name of every product and the number of orders that are tied to it, and we did all this without using a join or a group by or anything like that. All right. So again, I just want to mention that using a join or group by, probably both of them together, would be the ideal way of doing this without a doubt. I'm only showing you this approach with a correlated subquery just so we can get a better idea of what's going on here. And also to just reinforce the fact that whenever we're writing SQL, there is often more than one way to solve a problem. Okay, so that's it. Let's take a pause here and continue on in just a moment. There's just one last topic I want to mention around subqueries. When we are making use of a subquery, as we've seen, we can place a subquery inside of a select clause. But if we place just a subquery inside of a select, we can get away without putting in a from or a join or anything else like that. Let's take a look at this kind of scenario and why we would do it at all. All right, so the rule here is we can place the select keyword and then a subquery right after that without any other from or anything, as long as the subquery returns one single value. Let's take a look at an example of this right away, and then we'll discuss why we would ever do this. All right, so I'm going to put in a select, and then immediately put in a subquery. So for my subquery, I'm going to make sure I return one single value. So I'm going to try to calculate the max price out of all the different products. So we've taken a look at that before. It'd be select max price from products. Let's try running that, and sure enough, we get a result right here. So if we have a subquery that returns anything more than one single value, like let's say if it returns a column of values, we're going to end up with an error. If we try to return a group of rows and columns, so maybe price and name, we are also going to end up with an error. So we can only do a select with just a subquery if we are getting back one single value. So I'd put in max price again, and yep, sure enough, it still works. All right, so why would we ever do this? Well, this is actually really useful if we are ever trying to calculate just one single value that is the result of several other values. All right, that's not super useful to hear. Why would we really do this? All right, quick example. Let's say we want to find the ratio of the maximum priced item to the lowest price item. To do so, we might do something like select max, right there, we already found the max price item, and then we could divide that by the lowest price item, which we would find with select min price from products. So I can run that, and that will give us the ratio. Now in this case, we still see 9991 because the lowest price item is $1. So we're essentially getting 991 divided by 1. So we still get the same thing. We could try, how about the maximum price item against the average price of all items? So on the denominator right here, we could put in average price. And there we go. So that's actually a value that kind of makes sense. The maximum price item is about twice the average price. We can also print out multiple values from different subqueries. So let's say that we want to print out both the max and the average. Rather than doing the division right there, I could put in a comma. So this is now saying that we want to select the result of this subquery, which is the max price, and I want to also select the average price. So I can run that, and we get just those two right there. So you're going to be using this kind of select and then subquery anytime that you want to calculate just maybe one row of values, or anytime that you want to calculate the result of some math around a couple of different values combined together. All right, so now that we've seen this, last thing around subqueries, let's continue on in just a moment. Let's try a quick exercise where we're going to somehow select some data without writing a from clause in the outside query. So the goal here is to take a look at the phones table. You're going to find the maximum price, minimum price, and average price for all phones. The result is going to look something like this. So just the 3 different columns and 1 row total. So each of these different values are the maximum price for all phones, minimum, and average. You should solve this by using 3 different subqueries. Each subquery is going to calculate one of these different values. So you're going to use the exact same technique that we just took a look at in the last video. All right, so go ahead and give this a shot, and we'll come back together in the next video and go over a quick solution. All right, let's take a quick look at a solution here. So without a doubt, we know that we need to write out 3 different subqueries. The first one is going to calculate our maximum price, then the minimum, and then the average. We're going to combine all these together with one single outside select statement. So we will put in a select. I'll then put in a set of parentheses, and inside of here, we're going to calculate the max price, and we'll make sure that we rename the result of this subquery. So I will do a select max price from phones, and then rename the result to as max price. And that's pretty much it. We're then going to repeat that 2 more times. The next one will be a select min price from phones. I'll again rename it with a as min price. And then finally, select average or AVG price from phones as AVG price. And then a semicolon on the very end. All right, let's go ahead and check our solution. And after a brief pause, yep, looks like we got it. Cool. Well, quick pause right here. Continue in just a moment.